And so today we're just going to be going over some CADing best practices and how-tos. Some of you guys have been making CAD creations for your projects, and so we just wanted to go over how to properly model and 3D print.
Okay, so CAD stands for Computer Aided Design, and some programs that are usually used in the workplace or at schools are SolidWorks, AutoCAD, Inventor, and Fusion 360. Here we're going to be using Onshape since it's online and really easy to set up an account. You can just kind of use your school email and it's free. And yeah.
And so the first thing we're going to go over is sketches. Sketching is like a big part of CAD, and it's like the backbone of any of your 3D creations. So first thing, so sketches are created on a plane and are in 2 dimensions. And so you first want to choose your best plane to do your sketch on. So if you look at the model to your guys' right, you can see that it comes with 3 planes, which is your front, top, and right plane. And so these are kind of like the bases. You can choose these to start off, and then you can also choose like faces of your model that exist already to then make sketches on. And some best practices is to not reuse sketches for more than one type of feature. So if I'm going to cut extrude something, I'll make one sketch for that feature. I'll make another one if I want to do something that's also on that plane, but that's not the same feature. And it's also another good practice to start at the origin point instead of just having your first sketch be just floating freeform. And so here's some sketch relationships. So the relationships can be used to define shapes as well as set orientations of lines and objects in relation to another. So some of the common ones are concentric, coincident, parallel, tangent, horizontal, and vertical. You pretty much just click on what you want to make a relationship, and then you create that relationship. So coincident will pull 2 lines together. Coincident will make circles in like the center of each other and other things like that. And so here are some more sketch tools over here. This isn't Onshape, but this is SolidWorks. It's pretty much the same thing. All of your tools are the same. You have like lines, rectangles, different circles, different arcs, and each has a drop-down menu which you can select a different type. So for example, the arc has a tangent arc, 3-point arc, and a center arc. The circle, I'm pretty sure the circle you can do based on like you click in the top corner and make a circle, or the center. Rectangle you can click from the corner, and you can also do it from the center. So you can kind of just choose the best way you want to model something due to your needs. And some other useful sketch tools are convert entities, trim, and text. Text is also just another text tool, but it's kind of weird to define. Convert entities allows you to pull features from like other parts of your model into your sketch plane. So for example, if I want to make something flush, but I'm on the outside of my box, I can use convert entities to pull an inner angle and onto my sketch plane. Yeah. Also, you can use construction lines. Construction lines don't have to be defined, which makes them really good for construction. And sketches have to be closed shapes. You can't have anything open.
Thank you. All right, so I'm going to be talking about dimensioning. You have the slides. Okay, so dimensioning is how you assign lengths to each part. So basically, when you first start your drawings, you're going to be drawing your line or your circle, so on and so forth, and you're not going to have a specific length assigned to it. So with dimensioning, you're able to assign that length. So over here, you have an image of a fully dimensioned piece. You'll also notice that you don't want to over dimension, under dimension, which I'll get into a little bit later. And you really want it to stay organized, so you don't really want things overlapping each other. Okay, so there's going to be grayed out dimensions sometimes, and that means that there are driven dimensions. And I like to think of it as like independent and dependent. So basically, let's say you have, I'm going to erase this after. Let's say you have a rectangle and a rectangle, and you have a length here and a length here. If you were to decrease this length would increase. So one of them would be the driven dimension, and one of them would be the not driven dimension. So if you were to make this x plus 2, this would become x minus 2. All right, so overdimensioning and underdimensioning are both bad. So basically, you don't want something to be overdefined. So let's say you have too many lengths assigned to your part, the computer will not be able to actually tell you what's what, and the CAD will essentially break. It's a very similar thing for underdefined. So if you have a sketch that's underdefined, you'll actually notice that the lines are blue, and that's notifying you that you don't have a fully defined sketch. If you do that, that means that not all of your pieces are assigned in relation to one another. So that means that if you want to move one length or one piece of a rectangle, for example, the rest of it won't follow. So your sketch will break once again.
And another thing with that is once all of your lines are black and none of them are blue, you'll see that if you like try to click on any lines or anything, nothing will move. Everything's like set in stone. If you have anything blue, any dots, any vertexes that are blue, or any lines that are blue, then you can like pull things across, and then not everything is like set.
Yes.
And so next, I'm gonna talk a little bit about features. So some features are what actually make your model like 3D. So once you have a fully defined sketch, you can turn it into a 3D object. And some basic features are extrudes, cut extrudes, fillets, chamfers, linear patterns, and shell. I think that these are most. I chose these specifically because I think these are the ones that you guys are going to use most often in like what you're going to be making. And so here's the toolbar, and you can see the different features right here. A lot of them are more complicated, but I don't think that you'll have to use them. So an extrude adds material, cut extrude removes material, fillets like curve the edges of corners, and chamfers like slice off the corner. A linear pattern is just a pattern of a feature over and over again, and a shell removes the inside of your piece and with a specific wall thickness. So here's how it looks on Onshape. So it's a little bit different than like other CAD softwares that I've seen. But over here under extrude, you can either choose to add or remove, and that'll be either an extrude or a cut extrude. And then you can also set the direction or like how far you want it to extrude. So blind just means that it'll go a set distance and you choose the distance. So that's if I know that I want to make this thing 10 millimeters, I'll just use blind. But if I want it to go all the way through to a specific face, you have this drop down menu of things that you can choose. And yeah, and so it just helps you decide what you best need. And next, I'm going to talk about ordering features. This is just the order of which to do things, kind of like PEMDAS sort of thing. So you kind of want to start off by making like if I'm going to make a box, my first thing will be to make like a just an extruded rectangle, and then from there I can cut out things and I can shell it. And you also need to use logic to determine which feature happens before which other one. Because if I decide to shell something before I then make an extrude, that extrude won't be shelled as well. But if I put that extrude in front of the shell, then they will be shelled as well. So you kind of just need to think about what you're really looking for.
Okay. Thank you. So I'm going to be talking about some best practices, basically some do's and don'ts. Yeah. All right. So one really important thing is tolerancing, and there's a couple reasons why we do it. The first thing is that a printer is not 100% accurate. So if you're telling something to be, for example, this is actually accurate for any type of machining. Everything is not going to be as accurate as you want it to be, and if you want it to be more accurate, it's going to be more expensive. So let's say you want to print something that's like 0.02 of a millimeter, it could be 0.025, 0.019, etc., and so forth. And so that's not good. Another thing is, let's say you want two pieces to fit together. You do have to remember that in real life, lines actually do have some depth to them. So let's say you want to make a coffee cup, you have your cup and you have your lid. You want your lid to be ever so slightly larger so it can actually fit on top. Yeah. So another important thing is just the general ways that people kind of work in CAD is they use millimeters. I use millimeters. I think most of us do. Some people use inches, but it's not as common. So personally, like I have a preference as to how I tolerance. Everyone has different preferences, but at the same time, depending on how big your piece is and what you're making, you can actually kind of Google and have some advice on how what your tolerance should be. Yeah, so I kind of mentioned this already, but I guess I'm also leading up to what Chris is gonna be talking about. Yeah, your printer's not 100% accurate. It cannot take everything, and so you have to really consider whether or not your pieces are gonna be printable. Yeah. So the way that I'm gonna explain whether or not something is printable is if you're thinking about if you want to make a piece like this, you have to remember that the printer's going layer by layer upwards. So it can't really make a 90-degree angle and keep going. This is a hot liquid. It's plastic, so it's going to droop. It's not going to work. So you need supports holding everything up, and that's a waste of material and a waste of time. Please triple check your measurements.
Yeah, so another thing is like if you have a part that needs to slide into another part, make sure that your measurement isn't like just anywhere, but it's of like it's your largest measurement, like the largest size that needs to fit into a part. Make sure that that's like allotted for.
All you.
All right, so I'm going to talk about design for manufacturing. Basically, we have two 3D printers here, and if you're trying to 3D print something, they're going to be printed over there. And like Angelica said, 3D printers, there are like limitations to them. They're not just magic. They don't just pop out a 3D object for you, whatever you throw in there. Like you have to think about a little bit what exactly you want to like print and design it appropriately. Okay, so to first or to like know what to do, we need to first understand how a 3D printer works. And I think Angelica went over this a little bit, but the 3D printer, at least our 3D printers, are going to go layer by layer. So if we have an object like maybe a sphere, okay, this is 2D, but a sphere would print like a little dot first, then like a little line like that, like that, like that, right? And so it would just keep building up like this, right? And so you can see like a lot of it is not very well supported. It's all just supported by this like one little bit of plastic at the bottom. Sometimes this is okay, but sometimes it's not okay, and we'll talk a little bit more about that later. So basically, printer prints layer by layer, and then it's just plastic melted by the extruder head, which is like labeled with letter B, I think. And the print nozzle can move anywhere in the volume, which is what allows us to control and basically print whatever we want. Okay, so slicer. Does anyone know what the slicer is? Heard of a slicer? Yeah. Sure. This is anything more specific you want to add? That's right. That's right. Yeah. So the slicer basically turns your STL file or whatever file you put into the slicer into commands that the printer can understand, generates infill supports, and yeah, directs the printer how to move. Okay, let's talk about overhangs. Do people know what this is? Anyone? Rochelle? No? Do you know what an overhang is? Yeah. Right. So basically, 3D printers can't print on midair. I'm sorry, but that's just not how it works. And if you look at this diagram, this is what happens when you try to print on midair. So we need to generate something called supports, and your slicer does that for you. But it's not good for 3D printing because they waste time and material. So if you have a lot of supports in your on your 3D print, one, you could orient it differently, or two, you could build like just design it differently. So can anyone tell me how they would orient this piece to be printed so that it doesn't need supports? Yeah. Which part? This part, this part, this part? Yeah, I think they literally chose the worst, or actually this is like the second worst orientation to print it. Wait, go back. The worst orientation to print it would be on this side at the bottom. Anyone know why? Why it's worse than this? Yes. Yes. Like the supports would be going this way, like this, vertically this way, but there's also less contact with the build plate. So it has the same issue with the sphere printing, and so it might like slip off the build plate when printing. Yeah. Okay. So let's talk about supports. 3D printers can't print on thin air. They need something to print on, so that's the supports. Some 3D printers have like removable supports that are like dissolved in water. That's really cool, but we don't have that unfortunately. So we have to be more mindful of where we try to place our supports. Um, yeah, I've kind of said all of this, so try not to do anything with overhangs. Yeah, okay, that's the next slide. Okay, so let's think about this. What's the difference between this and this? Why is one better than the other? Why is it better? Yeah, so the supports would be generated like this, right? You can go to the next slide. Like that, right? And that look at that massive volume. That's like a waste of, like a lot of time wasted, and it's already a 3 hour print. This is I think this is Bradley's like thing, but like I just use it as an example. Yeah. But go to the next slide. Yeah, so is there something wrong with this? This doesn't really have supports, right? Maybe like a tiny bit for the edge right here. Is one better than the other? Yeah, that's right. So when printing, there's very little bed adhesion here, and like you said, center of mass is higher. So when the printer's moving around up here, it might like push the piece off by accident. So it's way better to print it like this, where it's more stable. And oh wait, go back. Sorry, one more thing. Also, there will be supports up here. And these type of supports are the worst ones, which connect from the piece back to the piece itself. They're hard to remove, rather than the supports that connect from the build plate to the piece. So yeah, it's worse. Okay. Let's look at this design. Oh, this is for, okay, this is another thing I wanted to talk about. Let's say we're building a case for our Raspberry Pi, right? Very simple. It's like two rectangular prisms. Um, yeah. Anyone see wrong with this? Or just like, it's like, yeah, I'm just saying it's just supposed to be a box that fits the Raspberry Pi. What could be like, yes. That's right. Right. So all this material right here, this entire volume is just wasted. And also look at how thick this part is. This is a 150 millimeter by 150 millimeter bed. So this is about like 1, 2, and 3. That's like maybe 100 or 110 millimeters long. So this is about like a centimeter and a half tall of just like straight like volume and infill. So that's all wasted, right? So instead, the person who made this, which was me, could probably like make it like a little thinner at the bottom, like right here, right? Instead of making this thick part right here and then also this excess over here. So really consider that when like doing 3D, when designing something for a 3D printer, because plastic costs money. It's actually really cheap, but like it takes time to do it as well. Yeah. Okay, so let's do a quiz. Anyone know the answer for number 1? What? Yes, that's right. Overhangs. And how many degrees? I didn't really say this explicitly, but it was on the slides. Yeah, 45. And the reason for this is like, it's like this. It's like it can kind of, each layer can kind of support itself with the previous layer. But if anything more, like maybe like this, like the layer is kind of like too far away to be like supported by the previous layer. Does that make sense? And so if you're at a 90-degree angle like this, then you like really are just printing on midair. Okay. And number 3, anyone? Give me a one reason. Yes. Time, yes.
Waste material.
Yeah. One more. Yeah. Sure, I'll take that. Okay. That's all I have, I think. Is there another slide? Yeah.
Yeah, so we're just gonna go over like quickly making a part on one shape.
Take this.
Oh yeah. Okay, so right here, this is like how your boot up looks like on Onshape. So this is when you don't have any sketches or anything. You can see here's your origin point and here's your front, right, and top planes. So you do is you first, if you want to make a sketch, you can make your sketch on your front plane. And then I'm just gonna make like a random shape.
By the way, feel free to follow along. I think it's really useful to, not just listen, but also try to get your hands on and, make the part yourself. So if you have any questions or walk us through the process, you can ask me and we can go around and help you out.
Okay, so here I've made a closed figure. You can see how it's closed. You can tell this is a closed figure because it's like slightly shaded in. But you can see that all of my lines are blue, except like this bottom one. But you can see that the vertex is still blue, which just means it's not fully defined. So what you do is you take your Smart Define tool here. I'm just gonna give these. And so another thing is like to define angles, or for like this angled piece, you can do it by length, but you should also just know that you can do angles by clicking between two lines like this. And now I'm going to use a relationship to define the rest of this. And so if I click this coincident right here, I can click this one and this one. Yeah, wait. Oh, not coincident, sorry. Horizontal. So make those two horizontal, and now this is a fully defined sketch. See, all of my lines are black, and all of the vertexes are black as well, which means that if I exit this tool, like I can't like drag any of these points or anything because it's like set in stone. So then from here, your sketch is fully defined, so you can just finish it. And then we just do a simple extrude. We do an add extrude. I'm just gonna do a blind. And you select your sketch that you want to extrude. Yeah, and so there we go. Now you see that we have a 3D model that's fully defined. And so then from here, if I want to like make a hole, I'll just start a new sketch on this plane. And then I could just put a hole here. And so see, now it's fully defined because nothing is blue. So you can exit your sketch. Do an extrude on this second sketch. And we're gonna do a remove. So now I see this will cut through. And so I can choose to extrude this blind and just make this, if I make this like 5 millimeters, you'll see that it only cuts part of the way through. But then I can also select to do through all. And then that means that it'll cut all the way through the part. And then the next thing I'll just show real quick is if you want to use shell. So if I am going to make this like a case for something or things are going to fit inside, you just click your shell and then you just choose a face. And then you want the shell thickness is going to be like the walls that are left. So 2.5 millimeters, that's fine. Yeah. And see? And so now we have a shell piece. Are there any questions? All right. Well, thank you all for watching.